Hi everyone! Today I wanted to talk about something called MCP. Now MCP stands for Model Context Protocol, and it kind of works as a bridge between LLMs and applications to let them directly interface and perform actions within applications. So it uses this client-server type architecture, and in this case, the target applications themselves would be the MCP servers. And they expose these standardized functions that are now callable from the MCP clients. So the MCP clients are communicating with the LLM. So effectively, it allows LLMs to add these defined functions as part of their tool belt to perform actions on your behalf. Now, what I did is I decided to try my hand at writing an MCP server, and for my target application, I selected Ghidra. Ghidra is a popular open source disassembler and decompiler that allows you to reverse engineer applications. So what I did is I took a ton of common reverse engineering tasks like analyzing functions, renaming function names based off of behavior, and I exposed all of that backend functionality as an MCP server to allow LLMs to automatically do all these tasks on my behalf. Now this effectively saves me a ton of time that I normally spend doing all of this tediously by hand, but it's easily automatable. Now the coolest part about this to me is that it's not just specific to one LLM, and it's not just specific to one application. Theoretically, you could have as many MCP servers as you want, and every single one is just an extra tool that's in the LLM's hands when it's trying to perform whatever task you're given. Now you may be saying, I already use LLMs. I have Ghidra on one side, and I have the LLM on the other side, and I just copy and paste information between the two, and it works great. But the nice thing about this is this allows the LLM to work autonomously and perform actions on your behalf. Now it has all of these standardized tools that you have made available for it, so it gets to work as an agent to perform the overall goal. Alright, now let's show MCP happening in action. So I have my MCP server here, which is actually just my Ghidra decompiler, and I've already loaded in an example binary that we're going to try to reverse engineer. Now normally when I'm reverse engineering an application, this is a super manual process, so I'll take a look at the code and start renaming all of the variables, all of the methods inside of here, to try to get an overall idea of what this messy application is actually capable of doing. But why don't we let our MCP client do all the work for us? Now in this case, my MCP client is actually just the Claude desktop application, and I have equipped it with all of these tools from my MCP server, so it's able to directly connect to Ghidra and automatically perform all of this analysis for us. Now these are all of the different methods available to it to be able to analyze this for us. Now I have this prompt here, so it's going to find the main method of the application, which is the one that I just had up in Ghidra, and it's going to rename all of the methods inside of it that the main method is calling, so we can know exactly what this method is doing. So let's let that run. Here we go. Alright, first it's going to try to find the main method. I'm going to allow it to use that tool on the background. And now that it has the main method it found, it wants to decompile it to see what it's doing, to see what methods it's actually calling. And there was the code, you could see that happening. And it's found all of the methods inside of this. So now it's asking for the permission to rename all of these methods based on their functionality so we can know exactly what they're doing. So I'm going to allow that. Please do all of the work for me. That's pretty cool. And it's renaming all of these. So hopefully this looks a lot nicer afterwards. We're just going to let that run. So now that worked, it looks like it renamed all of the methods inside of our main method to a lot more descriptive method names. You can see they were kind of messy before, so it analyzed all of these, decompiled these, and now it's giving us new names. And normally I'd have to do that myself, but now I don't have to. So let's look at our main method again. This looks a lot nicer. It looks like it went through all of these different methods and renamed them for us, and now that's automatically fixed inside of our Ghidra application. Oh my gosh, that's so cool! talked a lot about how you could use different MCP servers, different MCP clients, but why don't we try a different MCP client other than the Claude desktop application? And there's quite a few different ones out there. This one looks pretty good so far, called Fire. I don't know how to pronounce that. This just lets you select different LLMs on the back end to perform your auto-analysis for you. So it's going to connect to my ghidraMCP server. So I'm going to open up that application. Let's go to Fire. And I have a prompt available. This is really small, so I'm going to read it. So it's going to use the tools available, meaning my MCP server connected to Ghidra, to find 20 interesting data items, maybe some strings, another common reverse engineering task inside of my Ghidra program to try to understand the functionality of the decompiled application. And what model am I going to select? I can select different Gemini here because I have that selected. I'm going to go with 2.0 Pro Experimental. We'll just see what that does. So I'm going to let this prompt go. And now it's connecting to the backend, listing the data items, doing the exact same thing that the Claude MCP client was doing. And here it's found some different data items for me, some strings that might be interesting. So it's kind of going through and finding stuff that it thinks might be relevant to me in my reverse engineering process. So this looks good. And I can select multiple different models on the backend. If I go to settings, you can see there's a lot of different ones available. So this is nice and more model agnostic, which I think is good. I've talked a lot about how to use MCP clients now, but I want to get into how it works actually on the back end and how we're connecting to the servers and what the servers actually look like. So let's go over to the MCP Python SDK. And this is what you can install in order to be able to declare MCP clients and MCP servers to be able to communicate with each other. It's just a protocol to allow like this common language between these applications and the LLMs. Now, the syntax is pretty simple. If you want to declare an MCP server, you have all of these tools that you can declare, and this is pretty much letting the MCP client know, hey, this tool is available. So if you remember when I was going through in Claude, you could see all of these different tools listed inside of there. Each one of these is declared with this tool declaration. Not only that, but you can also add resources. Let's say you want to interface with like a database or something. There are also capabilities of doing that. Let's move on to actually how to create an MCP server. So I'm going to go to my ghidraMCP, and I will put the link to this GitHub repository with the tool all available in the description of this video. So if you want to get going with it, feel free, test it out, see if you can do some automated analysis. So here we have my Python server, which is going to be my MCP server, and I'm importing the MCP SDK that I showed in the previous GitHub repo, and I'm naming it ghidraMCP. So if I want to see what tools are actually available, I declared a tool for every single functionality that I wanted the MCP client to be able to do and interact with Ghidra. So you see, I gave it list methods, list classes, decompile function if it wanted to be able to analyze an actual function. Now, when we were watching Claude do its analysis, what it was actually doing was just deciding which of these methods it wanted to call for every single task to try to complete the overall ask from me. So it's working as an agent to decide and run all of these methods on the back end. Now you can see I have all of these tools declared. That's kind of the standardized interface to let the MCP clients know what's available. And if I go over to Claude, you can see if we click on this little tiny toolbox, these all match those methods that I declared inside of my Python code. In order to get Claude, or really any MCP client for that matter, to connect to that MCP server in that Python script, we just pretty much have to point it to the Python script, so it automatically starts it and is able to connect to it on the back end. So I'm going to show in Fire. I think it's pretty good. I've already got my ghidraMCP. If I'm in my tools section, I'm going to turn that off so I can edit it. Let's do edit and just show what this is doing. So this is just making a config, calling it ghidraMCP, and then running it as a Python server in the background so it knows what is available to it. So this bridge MCP ghidra.py just declares all of those MCP tools that I was showing. Now you may have noticed that my Python code was a little bit limited and looked kind of small for all of the different Ghidra manipulation that I was actually doing. So let me show you here. What you can do for these MCP tools is you could put all of the functionality inside of an MCP tool's corresponding method. That's perfectly acceptable, but depending on the application, that can be a little bit challenging to actually put and have constantly executing in the background inside of an application. So for my use case inside of Ghidra, it was easier to have a local server running and make the corresponding requests in the background to Ghidra. And how I did that was I created a plugin for Ghidra that's constantly hosting that server, and then my MCP server is then connecting to it and making those requests. So the plugin in Ghidra is actually doing all of the main functionality inside of the application itself. So if I go back to Ghidra, and I want to see the plugins that are installed, I can actually see my ghidraMCP plugin. So I go to File, let's do Configure, it's Developer Plugin because it is executing 100% of the time. And you can see my little HTTP server with all of the corresponding code that the MCP server is actually connecting to perform these modifications in the background. And if you want to get even deeper in the weeds, let's take a look at the actual Java code that is interfacing with the Ghidra API. So I'm going to go over to Cursor here, and I've imported all of the necessary Ghidra APIs. I have a lot of jar files in here for Ghidra, so I can actually manipulate the program. And this contains the backend functionality that the MCP server is interfacing with. So we have kind of this long chain of events. We have our MCP client, which in our case was the Claude desktop application, connecting to the MCP server, which was the Python code that imported the Python SDK in there. And then behind that, we have this Ghidra plugin that has Java code that is exposing all of the backend functionality from the Ghidra API. So we have all of these different endpoints in here, and that's what the MCP server is actually making requests to, all of these different ones available. And if you want to see the actual code for the Ghidra API, you can see getting all the function names, getting all the class names, or all of these different common reverse engineering tasks that I want to be able to make available to my LLM to automate all of this for me. Now, the nice thing about all of this is I can keep on extending this functionality as much as I want. So it's only going to get better and better over time as I keep extending the tools that are available to my MCP clients. Not only that, but you can have many different MCP servers. You can have pretty much any MCP server that you want. If you think about it, you can build it, and then that is suddenly available to your LLM to be able to automatically perform tasks for you. And the other thing is it's very nice because it's kind of model agnostic. As models get better, you can swap those out. It's this nice common language and protocol between them to allow models to actually manipulate your machine and manipulate applications to be able to be more efficient. And additionally, you can provide more and more context over time. So it's really only going to become smarter. Let's say, for example, you figure out how to reverse engineer something. Well, you can just add that to the context of the model, and then going forward, it's always going to know how to perform these common tasks for you. So I think this is a very interesting capability, and I'm really excited to see where it goes. So thank you so much for watching, everyone, and as always, Lori Wired out.